to SSV tutorials. Today's topic is progressions. So progressions is very important chapter in 10th class examinations. From this chapter we easily get up to 8 marks. Okay, so that is where today the class progressions. So first, what is progression? What is progression? So I have to tell the definition of progression. A progression is a series that advances in a logical and predictable pattern. I repeat once again, a progression is a series. It is a number series that advances in a logical, means there is a logical relation in the number series, and predictable pattern, that means you have to predict the next terms also. That kind of number series are called progressions. So a progression is a number series. It advances a logical and a predictable pattern. For example, 3, 5, 7, 9, 11. So this is a number series. So here by observing this, you predict that this is a what series it is? Odd number series. And any relation between the first and second terms? Just find. The difference between these two is 2. And 5 and 7 is 2. And 7 and 9 is 2. And 9 and 11 is 2. Okay, so there is a logical relation between the before and the after number. Okay, so 3 and 5 are differentiated by 2, and 5 and 7 differentiate by 2, and 7 and 9 differentiate by 2, like that way. So by this way there is a logical relation, and you have to predict the next term also. By this way, what is the next term? Means by adding a 2 to the before term, that means 11 plus 2. So the next term is 13. These kind of number series are called progression. So there is a logical relation, and also you predict the next number. Take another example. 6, 12, 18, 24 and so on. Here also, by observing that these are all the 6 multiples. 6 2s are, 6 3s are, 6 4s are. Okay, so and there is a relation that the difference between 6 and 12 is 6, 12 and 18 is 6, 18 and 24 is 6. So there is a logical relation between the before and after numbers. Okay, by this way, what is the next number? Means prediction. We have to add this constant number, means 6 to this number. You get the next number. So 24 plus 6 is equal to 30. So by this way you predict the next number in this series. Okay, at the same time 4, 16, 64 and so on. What is the relation here? Just observing that 4 4s are 16, 16 4s are 64. That means every before number multiply with 4, you get the next number. And 16 also multiplied with 4, you get the next number. So there is also a logical relation, but by the multiplication. So what is the next number? Means what you have to do? By multiplying 64 with 4. So 64 4s are 256. This is called progression. Understand? So a progression is a series that advances in a logical and predictable pattern. That means a number series having a logical relation between one to another. That means the consecutive terms having a logical relation consistently in the series. At the same time, you have to predict the next term also by this relation. That kind of number series is called progression. Understand? Next, types of progressions. How many types of progressions are there? There are 3 types of progressions are there. Okay, those are, one is arithmetic progression, AP. Second one is geometric progression, GP. And the third one is harmonic progression, HP. Progression is arithmetic progression. So what is arithmetic progression? So the definition of arithmetic progression is, in a progression, the difference between 2 consecutive terms is always constant. That kind of progression is called arithmetic progression. I repeat once again, in a progression, a number series, the difference between 2 consecutive, means 1 by 1, 2 consecutive terms is always constant. The difference between the 2 consecutive terms is always constant. That kind of progression is called arithmetic progression. And the definition also there. In a progression, the second number is obtained by adding a fixed number to first one. So in a number series, the second number is obtained by adding the fixed number to the first number. That means, for example, here 5, 10, 15, 20 and so on, it is a number series. Okay, here by observing that 5 and 10, according to the first definition, the difference between 5 and 10 is 5. 10 and 15 is 5. 15 and 20 is 5. That means, according to this definition, the difference between two consecutive terms, consecutive means 1 by 1. 5 and 10 difference is 5. 10 and 15 difference is 5. And the next consecutive, 15 and 20 difference is 5. Okay, so the difference between the two consecutive terms is always constant. So this number series or this progression is arithmetic progression. In other words, according to the second definition, the second number is obtained by adding a constant number to the first number. Means 5 plus 5, you get 10. 10 plus 5, you get 15. 15 plus 5, you get 20. So by using that, next term is 20 plus 5, next term is 25. So here the second term is obtained by adding a number and the third term is obtaining by adding a constant number. Here the constant number is 5. So these kind of number series is called arithmetic progression. So in a progression, the second number is obtained by adding a fixed number to the first one. To the first one, adding a fixed number, you get the second one. To the second one, adding a fixed number to get the third one, like this way. For example, 7, 10, 13, 16 and 19, it is a number series. Let us check, is this arithmetic progression or not. So the difference between 7 and 10 is 3. 10 and 13 is 3. 13 and 16 is 3. And 16 and 19 is 3. According to the first definition, this is arithmetic progression. Why? Because the difference between the consecutive terms is constant. So that is why this is a arithmetic progression. So according to second definition, a constant number is adding to the first number. 7 plus 3, you get 10. 10 plus 3, you get 13. 13 plus 3, you get 16. 16 plus 3, you get 19. So here, what is the constant number adding to the before number? 3. By adding a constant number 3 to the before number, you get the next number 10. So that is why this number series is also in the arithmetic progression. General form of AP. What is the general form of arithmetic progression? General form of AP is A plus D, A plus 2D, A plus 3D, A plus 4D, like that way. Means arithmetic progression forms by using this formula. Okay, so here A is called what? A is called first term and D is called common difference. So what is common difference means, from this example, here 11, 15, 19, 23, 27, it is a progression. In this, the first term is 11, so this is A. Okay, this is the first term of the progression, so it could be taken as A. And the second term obtained by what? What is the relation between these two? The difference between 11 and 15 is 4. And the difference between 15 and 19 is 4. Difference between 19 and 23 is 4. And difference between 23 and 27 is 4. So here the difference is common in between the consecutive terms. So that is where the difference is common. That's why that kind of difference is called common difference. Understand? So what is the difference in between the consecutive terms is constant. That kind of difference is called common difference. So here D, how much is D? So the difference is 4. That is why D is equal to 4. So this is the common difference. By this way, here first term is 11. The second term obtained by 11 plus 4. The third term obtained by 11 plus 4 plus 4. That means 11 plus 4 is the second term. You have to add the common difference to the 4, getting the third term. And the fourth term obtained by 11 plus 4 plus 4 plus 4, like this way. Means it can be written as 11, 11 plus 4. how many 4s here? 2 4s. So 11 plus 2 4s. And here how many 4s? 11 plus 3 4s, like this way. So this is the common difference D. This is A. So this is A. And second term obtained by A plus common difference is 4. D. Third term obtained by A plus 2 into common difference. 4 is common difference. So 2 4. 2D. And third term is A means first term plus 3 into common difference is. So A plus D, A plus 2D, A plus 3D. Like this way, this arithmetic progression formed. So that is why this is called the general form of arithmetic progression. In that, remember that A is the first term, D is the common difference. That means the first term adding D to get the second term. Second term adding D to get the third term. Third term add D to get the fourth term. So that is why arithmetic progression like in the same way. And also, how could you find the common difference if we given a progression? Means, so the common difference can be obtained by indicating with D. If it is a arithmetic progression, then common difference obtained by, this is the second term, this is the first term. So T2 minus T1. T2 is equal to second term, T1 equal to first term. So T2 minus T1, you get the common difference in a arithmetic progression.